आज चाहिँ we are going to study about physical optics. So what does physical optics deal about? It's the production of light, how is the light produced, the emission and the propagation of light, and the studies of various phenomena like we study interference here, we study diffraction, we study polarization here. So all these phenomena are associated with these physical optics. So in this chapter we are just going to talk about the wave nature of light. So since light carries physical nature like the particle nature as well as the wave nature, so particle nature we study in the modern physics, photoelectric effect, and here in physical optics we study about the wave nature of light. So first of all, what we need to know is the production of light. Production of light, that is electromagnetic wave. Electromagnetic wave. So how is it produced is the first thing. So if we consider any source of light, like there are sources like sun, which is very hot, and there are sources like bulb, lamps, so since we are considering the electromagnetic wave, so there is both electric as well as magnetic field. So we have got different sources of light, sun, which is very hot, bulb, lamps, etc. The first thing about the electromagnetic waves is the production of the wave. So what phenomenon goes there out there in sun, what phenomenon goes out there in bulb, all these things are associated with the electromagnetic wave. Whatever light we get, that is the electromagnetic wave, which is transverse wave. So here in this chapter, first of all we are starting with the production. So what happens there on sun is particles get ionized. Sun, bulb, and anywhere which is very hot. So we have got particles which are ionized. So at the point when charges are not separated, we consider it to be zero, the electric field. So charge gets separated little bit. Let's say plus moves little bit up, minus moves little bit down. So there is certain value of electric field produced. So it goes on little bit farther. So let's say at this point electric field is at peak value. So what happens there is very hot. So it's not like the charge goes on moving on one direction, negative goes on moving down, it's moving on up the same direction. Now what happens is there is a vibration of particles, so they keep on coming back or through. It's like there is simple harmonic motion of the ionized particles. So when it reaches the peak value, so again plus moves little bit down and minus moves little bit up. So here let's say the electric field is E2, and when it comes back to the mean position, again the electric field is 0. Now since the vibration is continuous, so what happens is minus moves up, plus moves little bit down. So here let's say it's E3, and let's say plus is here and minus is here. So the value let's say is maximum, but in the opposite direction, because electric field is always directed from the positive charge. So it is here downwards, it is here downwards, it is here downwards, here it's 0. So here it is upwards, so here it is upwards. So if we plot the graph of this electric field with time, like with the flow of time, this is happening. At some instant it's happening 0, E1, and then again at some instant it's happening maximum, and then again at some instant it's happening E2, and it's happening E0 again, so it's E3 in the opposite direction, and it's again maximum in the opposite direction. So finally, let's say the charge reaches the peak value and returns back. Let's say it's here, and let's say it's E4, and the charges finally come to the mean position, and the electric field is 0 over here. So if we try to plot the graph between electric field and time, so what we get here, now let's see. At this point it's 0, so let's say electric field, we plot electric field up, okay, on y-axis, and we try to plot time on x-axis. So at some point the value is 0. So if we plot the graph between electric field and time, let's say we take electric field on y-axis, so this is electric field, and let's say time we take here. So at point 0, let's say at the beginning of time, electric field is 0, it's over here. With the passage of time, electric field is directed downwards, so let's say it's directed downwards at some time. From here it's E1 over here, and after some time it reaches maximum. Let's say it's the maximum in downward direction, it's Emax. Now we plot E2, it's little bit here, and again at some point it's again 0, so it's, let's say, 0 over here. So again the electric field is directed upwards, and it's certain value over here, so let's say this one, and again it reaches the maximum value. Let's say it's over here, it's the maximum value. The maximum value should be equal, and it's E4 at some time, and it's, let's say, E4 over here, and again it reaches 0, it's again 0 over here. Let's say it's over here. So if we trace the free curve, we get that the nature of propagation is this way at some time. So here we find that electric field is changing its magnitude as well as the direction. So we see that along with the vibration of the charges, ionized particles, we see that electric field is at some instant, this is time, and at some instant it's E1, and at some instant it goes on increasing, and gradually it reaches the peak value where the vibration is maximum, and again it goes on decreasing when the charges come back to their mean position, and at this point it's 0. So now what does the charge do is they reverse their direction, and it reaches E3 at some instant, and it reaches gradually to E maximum, and it reaches E4. From the maximum in opposite direction, it just comes back to the mean position, and it's again 0. So from this we see that electric field is produced there in the form of a wave. So now whenever there is electric field associated with here with the charges, so wherever there is electric field, and the electric field is changing, of course, so wherever there is electric field, then there is the production of magnetic field as well, because if we consider the charge carrying conductors, like where the current is flowing, so what happens is around those conductors there is the production of magnetic field, and it is always perpendicular to the direction of electric field. So if this is the charge carrying conductor, then we see that current flows up in this plane, in the plane where we have got board, and now magnetic field is produced this way, like in this plane, it's circle, so it is associated with this plane. So these two planes are perpendicular, so there is a production of magnetic field as well, and it's in the plane that is perpendicular to this plane. So where is the magnetic field produced? Perpendicular, so we consider it to be here. So we've got this magnetic field over here. So if we see here electric field is generated on this E and T. Let's say this one is y-axis, this one is z-axis, x-axis. So in xy plane, electric field is produced, and in the xz plane, let's say this one is z, and in xz plane, there is the production of magnetic field. So here we see electric field is produced due to the vibration of charges. Now the magnetic field is produced due to the electrical association there, and the magnetic field produced is of varying nature, like the electric field is varying. Since electric field is varying, the magnetic field is varying. Now this varying magnetic field again produces the electric field, because as if in electromagnetic induction, Faraday has said that whenever there is change in flux, so flux is linked with this magnetic field kind of thing, and if the magnetic field change, obviously the flux change. So the change in flux caused by this varying magnetic field again produces the electric field. So this is how the electromagnetic waves are generated. We see here. So we further move into understanding the nature of wave, how it is associated with the things. So here what we see from here is electric field is perpendicular to magnetic field. Electric field is perpendicular to magnetic field, and both of the fields are traveling this way. So the resultant of electric field and magnetic field is the direction of propagation of the wave. So what we consider electromagnetic wave is the resultant of electric field that is coming to us, as well as the magnetic field that is coming to us. Two waves, and the result of two waves is what is coming to us as the light wave. Now we are going to study about the nature of wave, how the wave travels, and the things like phase difference, path difference. What does this thing actually mean? We are going to talk some basics about the wave. Okay, first of all, now we represent a wave in the simple way. Like this is the line of time, this is the line of vibration. If you consider here, so we see that we have always seen this is time and this is the displacement thing of the particles. So here is displacement, here is time. We plot the graph and we always represent wave this way. So what are the things associated with this wave is here, the representation. So now, does this thing actually exist? That is the first thing, because we everywhere see the things like this going on, but it's just that it's the representation of displacement with time. It's not necessary that these kind of things are coming to us, but when we represent the displacement and time in the graph, we represent in this way. So we consider the wave are traveling in such a way that the magnitude as well as the direction changes periodically. So this is the thing. So another thing, most important thing that we have to know about the wave is the path difference and the phase difference. So these are the things which are very important to understand, and यो चाहिँ अब अलिकति बेसिक बुझ्नै पर्ने कुरा चाहिँ हाम्रो पाथ डिफरेन्स र फेज डिफरेन्स हुन जान्छ। किन भन्दाखेरि अब म्याक्सिमम केसमा most of the students are confused with things like what is phase difference, path difference. We always do this, like whenever there is 2 pi of phase difference, then there is the path difference of lambda and all these things. So what are these things? So let's say at this point, this is the beginning of the wave. So let's say this is the beginning. So at the beginning, there is plus, there is minus. Now they start to vibrate. This goes up, plus, this goes minus. Now this is going up. Let's say this is going up, this is going minus is downwards. So these things go on vibrating till the maximum case. and again they come back. They come back at mean position, and again this goes on and it reaches the peak value. This one is peak value. Peak value. So now what we see here is the particles were going up like this. Particles were going up, okay, at initially, and finally we see that particles are changing their direction. So where do they go? Downwards, and again this come back here. So a complete wave is called that wave when from mean position it reaches the maximum position, again come back to the mean position, and again they in the opposite direction goes to the maximum peak value, and again they come back to the mean position. That makes a complete wave. So at that time, now see the particles, what is the direction, what is the angle that is made between the initial phase of vibration and the final phase of vibration? That is 360. We clearly see from that it is going up, it is coming again back, it is going up, it goes up, now it again comes back here. Now it again goes down and it again comes back. So it makes the angle of 2 pi. It is returning again back into the same position as it was in the beginning. So it makes 2 pi. Now this thing is called the wavelength. So here there is 0 degree, and it's here there is 2 pi. This is for the particles. And the wave, what is the distance traveled by the wave? The distance traveled by the wave is lambda, the wavelength associated with the wave. So this is the length thing, and this is the angle of the things. The angle between the beginning of the particle and the point where it makes one complete wave, and at that point too it is at the same phase like it was in the beginning. So what angle it makes is 2 pi, so 360 degree angle. And what is the distance traveled by the wave? Lambda. So we always say that for lambda path difference, we have 2 pi phase difference. We have got lambda path difference and we have got 2 pi phase difference. So this is always happening, as you can see, between the beginning of the wave and the end of one complete vibration. So what is the angle between them? 2 pi. Particles go up, now again return, now again go up, now again return. So till that point, the angle between the initial and final for a complete one wave is 2 pi, and the distance traveled by the wave is lambda. So lambda is the wavelength and it's the length. So path difference is associated with lambda and the phase difference is associated with angle. It's 2 pi. What we see here, यो इनिशियल बिगिनिङमा पार्टिकल कस्तो थियो त भन्दाखेरि यसरी मैले यसलाई पोजिटिभ माने, यो नेगेटिभ माने हैन। यसरी पार्टिकल माथि गइराछ, पोजिटिभ माथि गइराछ, नेगेटिभ तल गइराछ, यसरी गइराछ। यसको बीचमा एंगल कति भयो? 180. Now again it comes back to the initial position. Now again it goes down and it goes up, and again it comes back. अब यतिखेर एंगल कति बनायो त? What is the angle made by the particle? What is the angle between the beginning and the end? Not the end, but it's the end of one single wave. So one complete cycle. So simple harmonic motion, we represent it by circle, even circle. So here you can understand by these two. So here is circle. Simple harmonic motion you can represent by circle. So for one complete vibration, particle would have gone this way, this way, this way, and what I said, go. Very high. The angle one. What is the angle? It's 360 degree. It's a complete circle. So what is the angle? Angle is 2 pi. Angle 2 pi गर्दाखेरि एउटा complete cycle produce भयो. So what is the length of that cycle? What is the length? एउटा simple तरिकाले बुझ्दाखेरि lambda भनेको के हो त भन्दाखेरि वेभले चाहिँ भाइब्रेसनको एउटा कम्प्लिट साइकल हुँदाखेरि पार्टिकलको भाइब्रेसनको एउटा कम्प्लिट साइकल हुँदाखेरि वेभले कति डिस्टेन्स ट्राभल गर्यो? व्हाट इज द डिस्टेन्स ट्राभल? दैट इज कॉल्ड द lambda. That is called the wavelength. So distance traveled is lambda and the angle between the particles is 2 pi. So this way we can relate lambda with 2 pi. So whenever there is lambda path difference is lambda. What is the phase difference? So we've got phase difference 2 pi. 2 pi, what is this? Phase difference. Phase difference. Now, if I consider unit path difference, what is the phase difference? 2 pi by lambda. So if I've got, let's say here, I write here, x path. So this is different thing and this is different thing. It's quite dirty, but it's okay. X path difference, there is 2 pi by lambda multiplied by x. So whenever there is x path difference associated with wave, the phase difference is 2 pi by lambda multiplied by x. We can consider this for the single wave, too, and we can consider this when there is the interference of two waves, superposition of two waves. So this is very important to remember, that lambda path difference makes 2 pi phase difference, and again x phase difference makes 2 pi by lambda multiplied by x phase difference. So we can deal these things with a single wave as well as two waves which are superimposed. So we can consider these things. So if we understand these basic things, then it causes a little bit kind of curiousness in our mind to study the further in the wave optics. So the study about light, the nature of light, the emission of light, the production of light, and the various phenomena of light, the study on these things date back long back. We've got like the concrete history about these things, that when did it start and all these things. Even Bas, the great philosopher, the great God's messenger, let's say, even he calculated the speed of light. So it was 3 multiplied by 10 to the power 8 meter per second of the modern days. So it was very back, but like the science believes in the fact. So we consider Bas as a myth. So that may not be true, but Newton was associated with many things, discoveries and all these things, mechanics, heat, light, all these things. He did almost all the good things in science, and thanks to him. So Newton in 1678, he just proposed a theory upon light. So his theory hypothesis was like light is considered to be consisting of a lot of tiny particles, luminous tiny particles, which were called corpuscles at that time. So what's the nature of corpuscles is when they enter some denser medium, so the denser medium pulls them, so attracts them. So on the basis of that thing, on Newton's mind, he proposed a theory that the speed of light in denser medium is more because the particles of the denser medium attract the corpuscles, and that in the rarer medium, the speed of light in the rarer medium is less because the particles are very rare. So this was the theory of Newton. So it could not prove any of the things. So later on, it was found that the speed of light is more in vacuum. So the greatest speed of light we have got in the world universe is that in the vacuum. That is 3 multiplied by 10 to the power 8 meter per second. So that theory failed. Another scientist, Dutch scientist, Mr. Huygens, great scientist. So he proposed a model of nature of light. It was the wave theory of light. So his discovery was very strong on its hypothesis that even today, when we study the wave nature of light, like interference, diffraction, polarization, all these things, so we consider the first thing we consider is that light is wave, and we consider that how the wave travels is based upon Huygens principle. So that somehow brought the wave theory of light. So whatever we study in wave theory of light, it is just the ठुलो देन हाइजेनको हाम्रो ठुलो देन. So Huygens somehow knew that wave light is a wave. अब यो wave त travel गर्ने हो, तर how does this travel? Wave need medium, so how does this travel? So he considered that there is some, like everywhere, even Earth, and wherever there is nothing, no particles, he considered that space where there is nothing, even there exists some kind of medium called ether, which transmit the wave. So basically, his fundamental idea was that light is a wave, and medium ether is propagating this wave, and light wave is longitudinal wave. So this brought the wave theory of light. So after that, our great scientist Maxwell proposed theory upon the electromagnetic nature of light, which proved that light wave was not the longitudinal wave, but rather it is the transverse wave. So after that, Einstein in 1905 found that these light things, when just hits on the metal, so what do? Is they excite the electrons, and this proves that these things are kind of particles. So this brought like particle nature of light. So we have got the particle nature of light as well as we've got the wave nature of light. So like the common people, what we do, we get confused when one thing shows two kind of nature. Oh my god, somebody says it's wave and somebody says it's particle. Let's relax. It's kind of thing associated with the modernity of science. We've come a long way into science. So finally, we find that light is both particle nature, that is emitting the particles, electrons from metal plates, and it behaves as the wave, which shows the phenomenon like interference, diffraction, polarization. So we finally conclude that light has got dual nature. So Huygens principle. अब यो हाइजेन्स प्रिन्सिपलले के भन्छ भन्दाखेरि पहिला सुरुमा त डिस्टर्बेन्स छ. लेट्स से वी कन्सिडर सन. वी हैव अलरेडी नोन दैट द चार्जेस गोज अन मुभिङ अप डाउन अल दिस पिरियडिक मोसन. त्यहाँनिर डिस्टर्बेन्स त छ. अब त्यसको मोसनको कारणले डिस्टर्बेन्सको कारणले वेभ त ट्राभल गर्छ. फर्स्ट अफ अल लेट्स से दिस द फर्स्ट सोर्स and it emits wave. It emits wave in this direction. It emits wave in this direction. It emits wave in this direction. अब हामीले यदि सेम फेजमा भएको छ कोही फिजिकल क्वान्टिटीहरू जुन चाहिँ सेम फेजमा भाइब्रेट गरिरहेछ तिनीहरूलाई इन्क्लुड गर्यौँ भने हामीले यस्तो खालको क्लोज सर्फेस पाउँछौँ. यसरी हामीले एउटा क्लोज सर्फेस पायौँ। अब यो क्लोज सर्फेसलाई हेर्दाखेरि हामीले के पत्ता लगाउन सक्छौँ भने अब यहाँबाट यो एउटा वेभ हो। लेट्स कन्सिडर दिस कर्व्स आई एम ड्रइङ इज वान वेभ एसोसिएटेड हियर। अब यसको लोकस हामीले यसरी ड्र गऱ्यौँ भने यसलाई यो भनेको चाहिँ फर्स्ट प्राइमरी डिस्टर्बेन्स हो। यसलाई हामीले के भन्छौँ त भन्दाखेरि वेभ फ्रन्ट भनेर भन्छौँ। फर्स्ट थिङ हामी यसलाई के भन्छौँ वेभ फ्रन्ट भनेर भन्छौँ। अब वेभ फ्रन्ट भनेको के हो त भन्दाखेरि वेभ फ्रन्ट भनेको केही होइन, इट्स द लोकस। सो वाट इज वेभ फ्रन्ट? इट्स द लोकस, इट्स द लोकस it's the locus of the points. भाइब्रेसन त्यो पनि केमा हुनु पर्यो भन्दाखेरि सेम फेजमा हुनु पर्यो। कस्तो सेम फेज भन्नाले भन्दाखेरि यहाँ अब यहाँबाट एउटा एउटा कम्प्लिट साइकल फर्स्ट वेभ, यसको पनि यो फर्स्ट वेभ फर्स्ट वेभ फर्स्ट वेभ। अब हामीले लोकस ड्र गर्दाखेरि चाहिँ मानौँ मैले यो लाइन चाहिँ यहाँनिर ड्र गरेँ यो वेभमा। अब सेम फेजमा भनेको मतलब कस्तो त भन्दाखेरि लोकस बनाउनु पर्यो हामीलाई सेम फेजमा भने यो पोइन्टलाई यसरी यो डट डटलाई मैले यसरी ड्र गरेँ भनेपछि यहाँ यो पोइन्ट र यो पोइन्ट के छ त सेम फेजमा छ। अब मैले यहाँ पनि ड्र गर्न पाएँ वेभको अब 3/4 भागमा 3/4 पार्ट। अब यहाँ ड्र गऱ्यो भने यो पोइन्ट र यो पोइन्टसँग एसोसिएटेड भयो, यिनीहरू दुईवटा सेम फेजमा छ। यो पोइन्टलाई कन्सिडर गऱ्यो भने पनि आधै वेभले पनि हुन्छ, कम्प्लिट वेभ लिनु पर्दैन। लाइक द सोर्स पोइन्ट इज हियर, वी क्यान कन्सिडर हियर, बट वी हेभ टु ड्र द लोकस। सो वेभ फ्रन्टको लागि हामीलाई चाहिने भनेको के हो त भन्दाखेरि एउटा लोकस हो। वेभ फ्रन्ट भनेको केही होइन, एउटा लोकस हो जहाँनिर चाहिँ पार्टिकलहरूको भाइब्रेसन जुन चाहिँ वेभसँग एसोसिएटेड भएको फिजिकल क्वान्टिटीहरू हुन्छ लाइक द भाइब्रेसन दे आर एट सेम फेज। सो द्याट मेक्स अ वेभ फ्रन्ट। अब यहाँ हाम्रो हाइजेन्स प्रिन्सिपलमा के छ भन्दाखेरि हामीले एउटा पोइन्टलाई कन्सिडर गरौँ, यसले डिस्टर्बेन्स प्राइमरी डिस्टर्बेन्स दियो। अब प्राइमरी डिस्टर्बेन्स कसरी हुन्छ भन्ने कुरा वी हेभ अलरेडी टक्ड अबाउट द्याट एन्ड दिस इज द प्राइमरी डिस्टर्बेन्स लेट्स से। अब हाइजेन्स प्रिन्सिपलले के भन्छ भने फर्स्ट प्रिन्सिपल वी क्यान डिभाइड दिस थिङ्स इन्टु मेनी पार्ट्स, बट अब हाइजेनले दिएको प्रिन्सिपलहरू चाहिँ सबैमा इन्क्लुड चाहिँ हुनु पऱ्यो लाइक वेन वी डिभाइड। सो वाट इज द बेसिक कन्सेप्ट अफ हाइजेन्स प्रिन्सिपल इज एभ्री पोइन्ट अन द डिस्टर्बेन्स, कुनै पोइन्टहरू डिस्टर्बेन्समा हामीले कन्सिडर गरौँ, एभ्री पोइन्ट अन द डिस्टर्बेन्स एक्ट्स एज द सोर्स फर द सेकेन्डरी वेभ फ्रन्ट्स। अब यसले के गर्छ अरे हरेक पोइन्टले के गर्छ अरे त डिस्टर्बेन्स सेन्ड गर्छ अरे। एभ्री पोइन्ट सेन्ड्स द डिस्टर्बेन्स, प्रोड्युस द डिस्टर्बेन्स लाइक द सोर्स इट सेल्फ प्रोड्युस द डिस्टर्बेन्स। अब यसको डिस्टर्बेन्स हामी मानौँ यस्तो खालको छ, यसको डिस्टर्बेन्स 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 यस्तो छ, यसको डिस्टर्बेन्स यस्तो छ, यसको डिस्टर्बेन्स यस्तो छ। These things, these round kind of circles thing that the disturbance produced by the point, these are called as the wavelets. पहिलो प्रिन्सिपलले के भन्यो हाइजेनको भन्दाखेरि कुनै पनि वेभ फ्रन्टको हरेक पोइन्टले चाहिँ नयाँ सोर्सको काम गर्छ। नयाँ सोर्स हुने बित्तिकै त्यसले डिस्टर्बेन्स पठायो, डिस्टर्बेन्स हामीले बनायौँ। अब त्यो डिस्टर्बेन्सलाई हामीले के भन्छौँ त भन्दाखेरि वेभलेट्स भन्छौँ। त्यो डिस्टर्बेन्स वेभलेट्स हुन्छ भनेर फर्स्ट प्रिन्सिपलले भन्यो। अब सेकेन्ड प्रिन्सिपलले के भन्यो त भन्दाखेरि यो डिस्टर्बेन्सहरू जुन वेभलेटहरू छ त्यसमा हामीले ट्यान्जेन्ट बनायौँ भने, ल मानौँ यो अलिकति मजाको नहुन पनि सक्छ, लेट्स कन्सिडर दिस एज अ पर्फेक्ट ट्यान्जेन्ट, वी क्यान कन्सिडर इट। यहाँ ट्यान्जेन्ट बनायो भने त्यसले चाहिँ नयाँ के दिन्छ अरे त वेभ फ्रन्ट दिन्छ अरे, नयाँ वेभ फ्रन्ट दिन्छ। त्यसलाई हामीले के भन्छौँ त सेकेन्डरी वेभ फ्रन्ट भनेर भन्छ सेकेन्डरी वेभ फ्रन्ट यसलाई हामीले के भन्यौं त भन्दाखेरि सेकेन्डरी वेभ फ्रन्ट भनेर भन्यौं अब यो मात्रै त टेन्जेन्ट होइन पछाडि पनि टेन्जेन्ट छ वेभको टेन्जेन्ट टुवर्ड्स द सोर्स टु सो लेट्स कन्सिडर दिस वान टेन्जेन्ट ओभर हियर किनकि हाइजेनले त भनेको त टेन्जेन्टले त नयाँ वेभ फ्रन्टको काम गर्छ भनेर अब अर्को पोइन्टले के भन्छ हाइजेन्स प्रिन्सिपलको भन्दाखेरि सेकेन्ड पोइन्ट द थर्ड पोइन्ट एनी पोइन्ट के भन्छ भन्दाखेरि यो वेभ फ्रन्ट जुन चाहिँ हामीले पछाडिको सोर्सपट्टिको लिएको छौँ त्यसलाई चाहिँ हामीले के गर्छौँ त भन्दाखेरि इग्नोर गर्छौँ वी इग्नोर इट वाइ टु इग्नोर इट भन्दाखेरि अब यो सोर्सको नजिकै भएको प्राइमरी पनि यहीँ छ अनि अब यो यसले प्रोड्युस गरेको जुन चाहिँ डिस्टर्बेन्स छ त्यसको इन्टेन्सिटी कम हुन्छ एन्ड मोर ओभर अब यो त सेकेन्डरी भयो यसकै लागि यो सेकेन्डरी भयो भने यसले प्रोड्युस गरेको त यो सोर्सको नजिकैको त बढी इन्टेन्स हुन्छ इट्स मोर इन्टेन्स सो द्याट वी नेग्लेक्ट इट अर लेट्स से अर्को वेमा भन्दाखेरि यो वेभ जुन चाहिँ सोर्सपट्टि मुभ गरिरहेछ त्यो त हामीपट्टि आउँदैन द्याट डजन्ट कम टु अस एन्ड सो इट डजन्ट म्याटर दिस थिङ्स डजन्ट म्याटर टु अस द्याट्स वाइ वी इग्नोर द्याट त्यही भएर जहिले पनि एभ्री टाइम वाट हाइजेन्स प्रिन्सिपल सेज द फरवर्ड वेभ फ्रन्ट्स द वेभ फ्रन्ट्स ट्राभलिङ फरवर्ड आर कन्सिडर्ड एन्ड द वेभ फ्रन्ट ट्राभलिङ ब्याकवर्ड आर जस्ट नेग्लेक्टेड दे आर इग्नोर्ड त्यही भएर यसलाई हामीले के गर्यौँ त इग्नोर गऱ्यौँ अर्को प्रिन्सिपल के भन्छ हाइजेनको भने दिज वेभ फ्रन्ट्स द डिस्टर्बेन्स द टेन्जेन्ट अन द वेभलेट्स यु क्यान से एनिथिङ द लोकस दिज वेभ फ्रन्ट्स travel at the speed of light. So these travel at the speed of light. अब हामीले वेभ नेचरलाई रे नेचरसँग जियोमेट्रिकल नेचरसँग हाउ कुड वी एसोसिएट इट अब अर्को प्रिन्सिपलले हाइजेनको के भन्छ भन्दाखेरि द रेज अफ द लाइट्स are perpendicular to the wave fronts. So if we consider this as a wave front, let's say we consider this thing as the wave front, then we draw the perpendicular line on it. These are the rays. These are the rays. So these are the rays. These are the wave fronts. So wave front and rays of light are perpendicular to each other. So these are very, very important and basic things we need to know on Huygens principle. So what does Huygens principle basically say is, the first thing, we've got the source, point source, and the disturbance are passed. अब डिस्टर्बेन्सहरू पास हुँदै गर्दाखेरि सोर्सबाट बाहिरतिर जाँदै गर्दाखेरि कुनै पोइन्ट हामीले कन्सिडर गर्यौँ हरेक वेभको किनकि एउटा पोइन्ट सोर्स छ भने त त्यहाँ चारैतिर डिस्टर्बेन्स पठाइन्छ इट सेन्ड्स द डिस्टर्बेन्स एभ्रिवेयर त्यो पोइन्टबाट हामीले कुनै डिस्टेन्समा कन्सिडर गऱ्यौँ त्यो पोइन्ट एउटा लियौँ अब यता अलिकता यतापट्टि अर्को पोइन्ट लियौँ जहाँनिर चाहिँ के छ त हरेक पोइन्ट लिँदाखेरि चाहिँ when we take every points, each and every points are at same phase point छ जस्तो सुकै छ सोर्स त्यसले डिस्टर्बेन्स पठाउँछ बाहिर डिस्टर्बेन्स पठायो अनि डिस्टर्बेन्स चाहिँ जुन चाहिँ डिस्टर्बेन्स चाहिँ प्राइमरीली पठाइयो त्यो डिस्टर्बेन्सहरूलाई हेर्दाखेरि वेभसँग एसोसिएट भएको पार्टिकल्सहरू फिजिकल क्वान्टिटीहरू सेम लोकसमा हामीले लोकस बनायौँ एउटा लोकस बनायौँ वी ड्यू द लोकस सो द लोकस हरेक पोइन्ट चाहिँ के हुनु पर्यो भने हरेक पोइन्टमा चाहिँ फिजिकल क्वान्टिटी अब इलेक्ट्रिक फिल्ड म्याग्नेटिक फिल्ड त्यसको फेज अफ भाइब्रेसन चाहिँ के हुनु पर्यो सेम हुनु पर्यो त्योहरूको सबैको फेज चाहिँ सेम हुनु पर्यो त्यसले लोकस बनायो त्यसैलाई हामीले के भन्छौँ त्यो लोकसलाई द्याट लोकस इज नन एज द वेभ फ्रन्ट सो लेट अस कन्सिडर द्याट इज द प्राइमरी वेभ फ्रन्ट एज इट इज सोन हियर अब प्राइमरी वेभ फ्रन्टको हरेक पोइन्टले सोर्सको काम गर्यो त्यसले चारैतिर डिस्टर्बेन्स पठायो पहिलाको जस्तै डिस्टर्बेन्स पठायो यो सोर्स भयो, यसले डिस्टर्बेन्स चारैतिर पठायो स्पेरिकल्ली। यदि पोइन्ट सोर्स छ भने स्पेरिकल्ली चारैतिर पठायो। चारैतिर हामीले एउटा के बनायौँ त, स्पेयर बनायौँ। पोइन्ट वेभफ्रन्टको पोइन्टले बनाएको स्पेयरलाई हामीले के भन्यौँ त, वेभलेट भनेर भन्यौँ। यसरी धेरैवटा वेभलेट बनायौँ। अनि हरेक वेभलेटमा टेन्जेन्ट हुने गरेर हामीले एउटा लाइनलाई कर्भलाई ड्र गऱ्यौँ। त्यसलाई हामीले के भन्यौँ त भन्दाखेरि वेभफ्रन्ट भनेर भन्यौँ। यसलाई हामीले के भन्छौँ, सेकेन्डरी वेभफ्रन्ट। अनि अगाडि बढेको वेभफ्रन्ट मात्रै वी आर कन्सिडरिङ द फरवर्ड मुभिङ वेभफ्रन्ट, बिकज द ब्याकवर्ड मुभिङ वेभफ्रन्ट इज नट कमिङ टु अस, so it doesn't matter to us. Another thing is backward wavefront are weaker because they are nearby the source, and even the primary wavefront is here, so that is more strong. So this primary becomes more dominant, and we can neglect these backward moving wavefronts. So another is these wavefronts, all wavefronts, electromagnetic wavefronts, these travel at the speed of light. And the last but not the least point is these wavefronts, we considering these wavefronts, and these wavefronts are perpendicular to the rays we consider in our geometrical optics. So we consider ray nature of light over there, and those are perpendicular to these wavefronts. So if we remember these things, it's very, 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 very easy, and it's these basic things that we need to understand. If you understand these basic things, it makes this physical optics a lot easier. And students make it tougher, like they feel that it's tough, but it's the basic thing we don't understand. And if we understand these basic things, so we can understand the whole branch of physical optics, the wave nature of light, interference we have got coming forward, diffraction, we've got polarization. We can do all these things very easily. Types of wavefront. So we have got here types of wavefront. We have got the spherical wavefront, we have got the cylindrical wavefront, and we've got the plane wavefront. So first one is the spherical wavefront. So this sphere, it's kind of sphere, and spherical wavefronts are generated by point sources. Like if this is the source, point source, and we consider the vibration in different direction, this direction, everywhere. So we have got disturbances here. Disturbance चारैतिर फैलिएको हुन्छ. And if we consider a locus of points which are equidistant from the source, that is the point source, then we find that these locus make a perfect sphere. So this one is called the spherical wavefront. Another type of wavefront is cylindrical one. So what kind of source produced cylindrical wavefront is? The line source. Let's consider the line source, and the disturbance are distributed in all directions. So if we draw the locus, so we find that it makes a cylinder. So this one is called as the cylindrical wavefront, because the disturbance are aligned in all directions from this point source. Here. So here the disturbance travel in all directions and make the cylindrical wavefront. So this is the cylinder, this is the wavefront, and this one is the source. Now, third one is the plane wavefront. Plane wavefront are like, if we consider the far away distance from the point source, okay, let's consider the big circle, big sphere. Then what we see is, this is the big circle, okay, this is the big sphere. If you consider certain length of the circumference of sphere or circle, then we find that this is a kind of plane. So these make plane, and these are called as the plane wavefronts. Similarly, अब यहाँनिर हेर्दाखेरि पनि अलिकति हामी टाढामा डिस्टेन्समा गयौँ भने, यहाँ जाउँ, यहाँ जाउँ, यहाँ जाउँ, अलिकति टाढा डिस्टेन्समा गयौँ भने यसले पनि के बनाउँछ त भन्दाखेरि प्लेन बनाउँछ। अनि यसलाई चाहिँ हामी के भन्छौँ त भन्दाखेरि प्लेन वेभफ्रन्ट्स भन्छौँ। अनि सन भनेको पोइन्ट सोर्स हो, अर्थ इज भेरी फार फ्रम द सन, एन्ड द वेभफ्रन्ट्स रिचिङ टु अस जनरली बेसिकली आर द plane wavefronts. So these are the different types of wavefronts associated